All right, we're going to look through a review for our test 13, which you see here is over lesson 62, 65, 66, 68, and 73. So let's just jump in here and get started. The first question here says a force of f of x equals x squared plus 2 sine x plus 2, where x is in meters, acts on an object. What is the work required to move the object from x equals 4 to x equals 6? Be sure your calculator is in radians. Well, we learned that on a force versus time graph, the area under the curve would be your work. So to find that, we're going to integrate. We're going to integrate from 4 to 6 of our function, force function, x squared plus 2 sine x, plus 2, and dx. And so we can put that into our calculator. So we want to go to math. 9 is the one that gives us the integral, and we want to go from 4 to 6 of our function, which is x squared plus 2 sine x plus 2. And this is in terms of x, and I do want to make sure our calculator is in radians. It is not, so there we go. And we can hit enter, and our answer is 51.439. So 51.439 joules. All right, so it's pretty simple. Just write an integral for that. Next one. A ball is thrown with a vertical velocity of 12 meters per second from a height of 10 meters high. Start with the acceleration due to gravity function and derive the velocity and position function. All right, and then we have a couple questions after that. So we know that on Earth, acceleration due to gravity is negative 9.8 meters per second, which if we integrate that, that'll give us our velocity. So our velocity function is the integral of our acceleration function, and that is negative 9.8t plus c. And then we want to find c. So what we do is we read through here and we see that there's a vertical velocity of 12 meters per second. And that's what we're concerned with here is the vertical velocity. So we know when it's initially thrown, when time is 0, the velocity is 12. So velocity is 12 when the time is 0, and we've done this many times, so we knew that c would be 12 here. And so our velocity function is v of t equals negative 9.8t plus 12. And then our position function, or our height function, is going to be the integral of that. So h of t is going to be negative 4.9 t squared, because the right here will become a 2, and then a 1/2 comes out front, plus 12t plus c. And similar to before, we see that this is thrown from a height of 10 meters. So that's our original height when the time was 0. And so we see, again, that c has to be, plus c is 10. And so our height function, I'm just going to squeeze it in here, height is negative 4.9 t squared plus 12t plus 10. So we have two of our answers there that we were looking for, our velocity function and our height function. Now we want to answer those other two questions. What's the maximum height of the ball, and how long will it take for the ball to hit the ground? Okay, maximum height, we talked about and learned maximum height is going to be when the ball obviously reaches its highest point, but it's going up, and then it has to come to a stop vertically and then come down. So we want our velocity to equal 0, and that will give us the time, and then we can plug that into the height function to figure out how high it went. So we'll come over here with this function. We want velocity to equal 0. So 0 equals negative 9.8t plus 12. Subtract 12 from both sides and divide by negative 9.8. So we're going to get negative 12 over negative 9.8. So 12 divided by 9.8. Our time is 1.224 seconds. Now that we know this time, we can plug it into our height function. And we get h of 1.224 is going to just be plugging this in. So I'm just going to put it in as the answer that we got here in the calculator. That will give us a more accurate answer. So we have 4.9 times our previous answer squared plus 12 times our previous answer plus 10. And the height at 1.224 seconds is going to be 32.04 meters. That's going to be the maximum height. And then the last thing we want to find is how long will it take for the ball to hit the ground? Well, the ball hitting the ground is when the height is 0. So we want to put 0 into the height function. So we're going to have 0 equals negative 4.9 t squared plus 12t plus 10. And we're going to go ahead and put that in the quadratic formula. So we got t is negative 12 plus or minus the square root of 12 squared minus 4 times a, which is negative 4.9, times c, all over 2 times a. And we want to figure out what that's equal to, so let's go ahead and do what's inside the square root there. In fact, let's take the square root. 12 squared is 144. And then we have minus, but it's going to be minus and negative, so we're actually going to add 4 times 4.9 times 10. 4 times 49, because, and we got 18. So we have negative 12 plus or minus 18.439 all over, and 2 times a is negative 9.8. Well, we're looking for a positive number here. So we're dividing by negative down in the bottom. So we want the top to be a negative because a negative divided by a negative is positive. So what we want is we want to subtract the 18.439. So we're going to do negative 12 minus our previous answer. We'll go ahead and hit enter and divide that by negative 9.8, which gives us a time of 3.12 seconds. And there you have the different answers they were looking for. The two functions for velocity and height, and then the height, the maximum height, and the time it takes to hit the ground.